So today I'd like to teach you how to do the photocell experiment. We're going to work with a photocell. And so we're going to put a photocell here. And we're going to put a light source here. And we're going to show how this interacts. So I've got a photocell here with a resistance meter. And so ideally the best is if you can do this experiment yourself, but if necessary for some reason you can't get access to the materials, you can use the data that we have here. But I do suggest if you do the experiment you'll learn a lot more about this. So what you want to do, you can either have a partner hold the photocell for you, or you can mount it. I've just made a little stick with a weight on it here, to which I'm going to mount the photocell. And so it's weighted down and it sits on the table around the same height as the light. And then I'm just going to simply move the move this back and forth away from the light. So if I turn on this light here, I've got the photocell, and you can see when the photocell is close to the light, it's reading a fairly low resistance, like 17 ohms, 16.8. And as I move it further and further away, the resistance goes higher as it gets further away from the light. And so we could do this experiment with a tape measure, and we could measure the distance away from the light. But I want to show you how to do it quantigraphically, how to do it comparametrically, how to do it without using measuring instruments. So there's something very interesting about measuring without measuring instruments philosophically. It's a philosophy called comparametric sensing and comparametric analysis. And it unlocks a lot of key mathematical capabilities that are quite interesting. So what I want you to learn is how to do this comparametrically, how to do it without instruments, without a tape measure. So no tape measure needed. And so let's do it without instruments. Other than this is not really considered a measuring instrument because this is part of the camera. So we've made a sensor, which is a photocell and a voltmeter or ohm meter. The photocell and the ohm meter together are the instrument under test. So this is a highly nonlinear sort of sensing apparatus, and we want to understand it, quantify it in some way, quantimetrically, relatively at least. So the way we're going to do this is we're going to introduce a piece of black cardboard that we can use to cover up exactly half of this light, and then we're going to put the photocell here, and we're going to measure how much light there is when it's half covered. So let's start. Let's slide it down the table here towards the end of the table. And so we're going to measure. First we're going to measure how much light there is. We're going to measure how much light there is, what the reading is. At the moment there's 175 ohms, 175 roughly. So let's say 175 ohms. We'll make a table here. 175 ohms is there, and then we're going to cut that light in half. So we're going to make this table. Then we're going to cut this light in half. So we're going to drop it to half the light. We're going to cover up half that light bulb. And then we're going to look at the ohms again. And now it's a higher number of ohms. It's 219 ohms. So it's 219 here. And this is half the amount of light. So this is some quantity of light, Q, say Q0, and this is twice that quantity, 2Q0, or we could say Q0 here and half Q0 over here, but this is twice the amount of light than what's over here. So what we're doing now, what we do, the key step here is to move this closer, slide it closer until that voltmeter, the ohm meter reads the same amount until it reads 175 ohms. Keep moving it closer until it reads 175 ohms. Now, it reads 175 ohms when it's this distance apart. We slide it back and forth until it reaches 175 ohms. And then we take this black cardboard away to double the amount of light. And we read what's on the meter. Now it's 130 ohms. So now the 175 is over here. We just bring that down and write the 130. And then what we're going to do is we're going to now do the same thing again. Now move it closer again until it gets down to 130. And then we're going to bring the 130 over here and then take this away and note what the reading is. So if we take this away, we see that it's 84 ohms. So it's 84 when we take it away. And then now it's back to 130 because I put it back. And then now we're going to slide this closer until it gives me the same reading. I'm going to bring it closer. Oh, too close. Until it reads to 84. That's about 84 there. Just a little less. That's about 84. So now we're going to simply take this divider away and double the light again and look at the value, and now it's 65.7, 65 and a half. So say we gone down here, we take this 84 across 84 and then 65.5 and so on. So we're going to just keep doing this. Now one of the things is we could improve the accuracy here, because one of the obvious things is there's a lot of other light sources in the room. So what we ought to do is turn down some of these light sources and see if I can darken the room a little bit, turn off some of these lights that are in the room, turn off some of the TV screens that are in this room. Let's try and turn off some television screens. A big TV over here that's showing my photocell experiment paper, and I'll turn that off for a moment. And as I go around the room and try and find light sources that I can turn off on my workbench, I've got this overhead fluorescent light. I'll turn that off. And then I've got some lights in the furnace room over here that I can turn off. And what we want to try and do is turn off more and more of these lights, making it darker and darker to the point where hopefully the only light source, and there's a light bulb up here, I can just loosen that bulb just a little. And so now it's a little bit darker in here. And so now pretty much the main source of illumination is that one light bulb. I can close the door here and make it a little bit less light leakage. So, and the only other source of illumination is the street. There's some street lights out there. So I'm going to face away. See, I've got my photocell facing the darker side of the room, not facing the street, because there's a streetcar goes by there and so on. There's a car going by. There's some street lights over there. So we want to try to cut down the amount of light, so we'll face this way. And it's best to wear black. I'm wearing black clothes, which is my favorite color. So now we'll do the experiment again, but this time we'll have a slightly more accurate result because we don't have other sources of competing light. So let's start over. Let's start fresh here. And what I've done is, what I'm doing is I'm covering the bulb with a piece of black paper each time. So I'm just covering half the light bulb with the black paper. Now I could have a partner doing this, but at the moment I just made a little piece of black paper cardboard on this little weight. I just put it onto a little weighty thing so it sits on the desk there, and I've got a little weight sitting on here, so this thing just sits and holds the photo resistor. And so I've got the photo resistor right there, and I've got the light bulb right here, and I'm going to simply at the moment just slide that back and forth and measure and take some measurements. So let's do that again. I'll move this, say, here, and this over here, and we now have 199.8, 200 ohms. Let's call it 200 ohms. It feels like about 200, and as I move around it affects it a little bit, but not too much if I stay mainly out of the light path. So let's say I've got over there 200 ohms, and I'm going to do I'm just going to take my list as 200 ohms, and then when I cover exactly half that light, and it's pretty easy to guess half. It's hard to guess a third because that bulb's not even round, so it'd be hard to do a third or some other number, but it's very, very easy to do a half. I can pretty much sight that up and estimate. If I'm lining this up, I can pretty much estimate where about the halfway point is on that bulb, and what is about half of the light bulb. So now when I go to half, what I'm seeing over here is I'm seeing roughly 416 ohms, 412 ohms, 13, actually 413 ohms, let's say 411. It's kind of fluctuating around 410, 9. It's sort of dropping a little bit, and then it's coming back up. So there's some background noise there. And it went up to 410. So let's call it 410. So this is 410 here. And this is f of 2q. So this is q, and this is 2q for whatever value of q. q0, you could call that, and q1, and so on. So say this is q0, 2q0, and then bring this across. Get 200 here, and then we'll take this away once we move that across. So we're going to put this here, and we're going to move this up until such time as we see 200 ohms on here. I'm going to keep moving this closer to the light until it hits 200 ohms. We're going a little too far, 199, 197. That feels like about 200, right about there. That's pretty close. 199.8, that's not too bad. So that's 200 ohms when we move that across. That's what's happening here. We're bringing that down, and then we move this away. We tip this away and read what the value is, and the value is 157 ohms. And then we drop that back in again. 157. And so 2q is 157, and if we bring the 157 over here as the new q for the next round, we're going to move this closer until we hit this to 157. There we go. 154, just a tad too far. It's 150. There, 157. And then we're going to tip this away, and we're going to see what that says, and that says 130. And we'll put it back there. That's 130. And then we do the same thing, bring that down until we move it in until it gets down to 130. We're going to go down to 130 here, that's about right. And then pull this away. There's 130. And we pull it away. 130.6 is pretty close. And we pull it away, and we've got 112.8, 113, let's say. Let it come back. So that's 113. I'm just kind of writing down the numbers here, and then 113. And then we're going to move this in until we get to 113. 113 is right about there. And this is, now we'll pull this away again. And now we're at 103. So we got 103 is the next point, and then we're going to slide this over until we get it down to 103 ohms. 103. There's a streetcar going by right now. I guess I'll wait for that to go by because it's going to kind of bright. It might change the numbers a little bit, but hopefully not too much. So now the streetcar is gone. I'll push that back to, yeah, that's about right, 103 ohms. And then I pull this away and see what it reveals. It reveals 98.7. I'll just maybe take it to 3 sig figs, 98.7. And then we want to pull this in until we get to 98.7. 89, 90, 98.7. And then that actually, you got to get it in a little bit better. That's about right. .7, and then pull it out, and it goes to 81.7, and then bring it in again. Keeping it about half illuminated. .7, so roughly, and then order list a little bit. Yeah, that's good. And then doubling it up, it goes down to 53.7. And then move it in closer until it gets down to 53.7. That's that halfway, half covered roughly. 59. That's about as, kind of getting about as close as I can get it before it's hitting the bottom here. 53.7, and then we just double it again. We'll pull it back, and that is that was 53.7, and now we're at 34 ohms, 34.1. See, 34.1. So that's kind of about as far as we've taken it. So that's quick. There's some approximations here. The main thing is I want you to learn how to do this and what it means. More important than getting accurate measurements is to learn what it means. So we're covering half the light and we're doubling it. So we're doing this successive reduction and doubling of the quantity of light. And then we've got this ordered list of numbers, 410, 200, 157, 130, and so on. And we drop those numbers down. So you can use those numbers if you want. But I would suggest the best thing is to collect your own numbers, because I did this fast and sloppy. You can do it a little more carefully.